So in 2.4, we're talking about compound interest, right? And we've already talked about simple interest, and that was just this, where we're just kind of earning a fixed amount, a fixed percent of interest on whatever we initially put into the account. Well, with compound interest, we're kind of earning interest on our interest, right? What compound interest is doing is it's taking the balance repeatedly and then recalculating interest, and sometimes that balance winds up including interest that's already present. So you kind of earn interest on your interest. It's technically a better way to make money usually in a savings account. And it's this formula here, this A equals P times 1 plus R over N to the NT. So instead of dealing with just the interest awarded in simple interest, the compound interest formula actually gives you your account balance. So it just spits out your account balance, and then if you wanted to know just the interest earned, you'd have to do a little extra work. P is still your principal. That's still your starting amount. Principal. R is still your interest rate. And remember, we have to convert that from a percentage to a decimal. Right, so remember that, right? Our 2%, we would move 2 places to the left. It would become 0.02. I can start working decimals into my percents. It still wouldn't matter. Still move 2 places to the left, right? I go 1, 2. T is still time in use, but this N is new, and maybe I'll do it in a different color. Right, this N is new, and this N represents the number of times interest is calculated per year. So if I were to say something like calculated annually, if I compute compound interest annually, then N is just 1. If I were to say something like monthly, N would be 12. If I said daily, you could assume a non-leap year, and you could say 365. Weekly would be 52. Quarterly would be 4, and so on. But these are kind of the two that I think you see the most frequently, annually and monthly. So let's actually put this to work here and try a couple problems. So here's my first example. Chris wants to open a 3-year CD through Washington Trust with $1,500. The CD earns 3.25% interest compounded annually. What is the balance of his CD when it matures? Well, if you're not a big fan of word problems, the first thing you should do is isolate that given information. And you know that you're going to be dealing with compound interest here, so we can just start with the formula. And I want to write off all my variables onto the side and actually figure out what I've been given. So we want to open a 3-year CD. So that tells us that our time is 3. And we're going to open that CD with $1,500. Well, then that's my principal, $1,500. CD earns 3.25% interest compounded annually. So 3.25%, we have to turn that into a decimal, right? So I'm going to move 2 places to the left. And I'm going to use that number instead of the percentage. Compounded annually, so there's my next kind of keyword here. Compounded annually, that's once a year, so N is 1. What is the balance of the CD when it matures? So this is what I'm solving for. I'm solving for A. Well, now I've got all my information isolated, which is going to make it a lot easier to calculate instead of trying to go back into the problem every time and pick it back out of the paragraph. It's a lot easier to have it all written out because now I can just go through and plug everything in. I think it's a lot easier also to calculate bits and pieces of this. So I'll simplify it inside the parentheses you can see I've done. I'll simplify the exponent as you can see I've done. And that way it's fewer calculator entries and fewer places I could maybe go wrong. Of course, this is dollars. And I get a final account balance of $1,650,105. So you can see over 3 years I've made about $150 in interest, which is just pretty good. One thing you want to be careful when I'm going from this step to this step. remember your order of operations. So in my calculator, I just entered exactly that line in, right? I just entered, pick a different color for my laser so it shows up better. I just entered 1500 parentheses 1.0325 parentheses exponent 3, and it gave me the right answer. Remember that your order of operations is exponents first. So I could never multiply the 1500 and the 1.0325 together. There's kind of an implicit set of parentheses here, right? So if you're ever stuck without like your graphing calculator, you got to do that exponent first, right? You've got to do that 1.0325 cubed first, and then multiply it by 1500. So be careful, be really, really careful with your order of operations. Let's take a look at a different example. We want to earn $1,000 in a savings account, earns 3% interest, compounded monthly. If she wants to keep the account open for 5 years and make no additional deposits, what must her principal be? And I've seen people kind of get lost in this no additional deposits line. This is just a formality to tell you that there's nothing kind of fancy or tricky happening behind the scenes. We're just going to deal with that one sum because our process actually does get more complicated when we think about having additional deposits, and it's something we'll actually talk about later. But again, I think it's easier to isolate all of my given information and figure out what I know. So we want to earn $1,000. So I'm not starting with $1,000. That's my goal. I want my account balance to be $1,000. That account earns 3% interest compounded monthly. So 3% as a decimal, 0.03. Compounded monthly is 12 times per year. Wants to keep the account open for 5 years, time is 5. What must her principal be? So here I guess I kind of come right out and say it. Right, we're solving for our principal. And I can jump right in with my formula. Plug in what I know, solve for what I don't. Again, that isolation step is really an organizational tool, and it makes it so much easier. So now we need to do some simplification. So I have 1,000 equals, let's see here, 1 plus 0.03 over 12. 2 to the 12 times 5 is 60. So we're at like 1.16162 p. And my last step would just be to divide. And I get a principal of approximately 860.87. And if she really wants to reach her goal, maybe she would round up to like 861 to make sure she makes that $1,000 goal. But in this class, 860.87 is good enough for me. So that's really the process, right? And again, order of operations, simplify your exponents first. So this number, this number just came from this piece right here. And it's at that point, it's just algebra. So just a short example to start with what simple interest is.